If you accidentally fell into Saturn, the very first thing you'd see is the planet's famous rings up close. You would quickly realize they aren't a solid structure at all, but a vast system made of countless ice crystals and rocky fragments of different sizes, all orbiting Saturn at tens of kilometers per second. Despite their beauty, each piece could hit you at supersonic speed. After about 10 minutes, you would pass through the rings and begin entering Saturn's atmosphere. Unlike Earth, Saturn has no solid surface. Its structure gradually transitions from gases into liquids and then to denser materials deeper inside. The outermost layer is mostly hydrogen and ammonia, with massive white ammonia clouds drifting through. As you descend, the sky would darken, turning brown due to clouds formed by hydrogen sulfide mixed with ammonia, filling the air with a strong, pungent smell. Temperature and pressure would rise relentlessly. 2 hours into the fall, you'd be completely engulfed by Saturn's atmosphere. Sunlight could no longer penetrate the thick gas layers, leaving you in complete darkness. At this point, winds would howl around you at up to 40 meters per second, several times stronger than Earth's most violent hurricanes. But wind isn't the only danger. Huge amounts of static electricity build up in Saturn's atmosphere, releasing lightning strikes thousands of times more powerful than those on Earth. Gigantic arcs would flash across the skies, alternating bursts of blinding light and thunderous roars, like a warning to any intruder. After 3 hours, you'd reach the water-ice cloud layers. The pressure would suddenly increase to 10 times Earth's atmospheric pressure, pushing your spacesuit to its limits. Each breath would feel like being crushed by an invisible force. The deeper you go, the hotter it gets. After 6 hours, the temperature would rise to about 10 degrees Celsius, 50 degrees Fahrenheit, and the thick gases would slow your descent. 8 hours later, you'd reach the layer of metallic hydrogen. Here, under immense pressure, hydrogen gas is squeezed into a strange liquid metal form, the very source of Saturn's powerful magnetic field. At this depth, the temperature would soar to 90 degrees Celsius, 194 degrees Fahrenheit, and the pressure would be 100,000 times greater than Earth's surface pressure. It would feel like being inside a blazing furnace. After 10 hours, you'd finally reach Saturn's core. The temperature here would spike to over 10,000 degrees Celsius, 18,000 degrees Fahrenheit, with pressures so extreme they can't even be measured. Scientists believe the core is mostly made of iron and ice compressed into a solid state, but you'd never see it. Your spacesuit would shatter under the crushing pressure and heat, and your body would be compressed instantly. Your mission would end there. Now, you might ask, if no one has ever fallen into Saturn, how do we know all this? The answer lies in science. Since Galileo first observed Saturn with a primitive telescope in 1610, scientists have been studying it. But the real breakthrough came in 1977, when NASA launched the Cassini probe. Cassini orbited Saturn for years, sending back thousands of images and massive amounts of data. It revealed Saturn as a giant gas planet with breathtaking, yet fragile rings. Scientists believe these rings may have formed from a moon that was torn apart by Saturn's tidal forces. Once it crossed the Roche limit, it could no longer hold together, breaking into countless fragments that spread around the planet to form the magnificent rings we see today. And here's a thought. If Earth's moon ever crossed the Roche limit, it too could be shattered by Earth's gravity and create a beautiful ring system around our planet. But Saturn's rings won't last forever. Influenced by the planet's magnetic field, the particles are slowly falling into Saturn. Scientists estimate that in about 100 million years, the rings will vanish completely, leaving only data and images for future generations to remember them by.